In this video we'll be taking a look at geometrical solids. We'll be looking at the various constructions of some of the geometrical solid objects and then taking it from basic construction and labelling of points and the key terms associated on to taking planes, cross sections through the object which show the true shape of a cross section of the object and truncating the objects, so cutting them at specific angles. And we're going to be dealing quite a bit now with these guys where you cut them at specific angles, and what you're creating when you cut at a specific angle is actually called a plane. This guy right here that's cutting this, what's that, a pentagonal based prism. This pentagonal based prism is truncated at an angle of about 45 degrees, and it's cut or truncated by this inclined plane right here. And that plane, there's just two terms that I'll be using, and one of them is called the vertical trace there. Basically where this plane goes in and hits the main vertical plane, we call it a vertical trace. A trace is a line of intersection. So we'll be dealing with the vertical trace where these extra planes hit our main plane. So vertical trace. And as you probably have guessed already, where this extra plane goes down and hits the horizontal plane, is called the horizontal trace. Just the shortened version is here, the VT for the line of intersection between our new plane and our original is the VT, vertical trace, and the HT, horizontal trace. So that's kind of the plan. That's what we're going to be doing now. We'll be also looking at some true shapes. So we're going to be taking this part here that's hatched is the actual cut. Now in the elevation, as you can see here, it just looks like one line. When you look down on plan, it actually doesn't really change. It is longer, but we're just looking straight down on top of the object, so all of these 5 faces around the object will still just appear as edges. It doesn't change the look of the plan. The plan just gets hatched exactly like that. But the next thing we look at then is maybe catching this plane from here along this line and hinging it out onto the ground, and later then for the next harder step is hinging it along here, catching it and swinging it up against the wall like that. So that's the plan. That's where we're going with this set of drawings. For now I'm going to get started with just this one right here, a nice easy one to start off with. It is on page 215 of your book. It's a rectangular prism, and it's quite a large drawing. I'm going to keep it over the right hand side of my page, and I'll actually do a rebatment as well, so a rotation that's going to show that cut surface right there. It'll show it as a true shape. So if you want to work along with me, page 215 of your book. And to begin, I'll start over here on this side now. I need a plan 70mm by 40mm. Leave a 10mm space there up to the elevation. And the elevation itself. Now, what we're dealing with here is before the elevation got cut, it was 110mm high. So we'll draw it full size for now, 110. Before it got cut or truncated, a full 110 high. And then it gets cut at a point, and it gives us the measurement there in the book. 25mm out, right there, is point T, and that's part of both traces. And the plane is at an inclination of 45, so my guess was My guess was right, that it looked like it was 45 degrees. I'm going to drop that plane in there in a different colour. So 45 degree inclination on this plane right here, slices through the object just like that, and the plane just stands straight out there. That means that I can heavy in the object until it hits the plane. There. And there. Now, the top of this plane is, or the top of this three-dimensional object is all just truncated, it's cut off. And along the green line there on the plane, well, it cuts the full object. Now, does that change what the plane looks like? No. And the reason being, if I actually was able to say, what does it look like across there? Well, it still looks like the exact same rectangle sitting on the ground. So when we're dealing with prisms, what you always need to remember, a full prism that height is going to look the same, looking down in plan, as a small prism this height. If we brought our cutting plane from its position right now, and if I brought it right into here, well, now I've altered what the plan looks like. The plan changes because I've cut away part of the profile. If any part of the profile, any part remains full, and this is only for prisms, by the way, if any part of the profile remains full, then the plan remains the same. It's going to be very different when it comes to pyramids and cones, but for prisms, which are taking a shape and extruding it straight up off the ground, if any part of that profile remains, which in this case a good bit of it here remains, probably about 25 or 26 millimeters of the same object remains the same, then the plan does not change. Now, to get a true shape here, if you were told in your question, well, first off, if you were told maybe like that is all a cut surface there. So because when you look down on top of this object, my cross hatching isn't very tidy there now. When you look down on top of this object, we're seeing the whole green plane cut through the surface from the top to the bottom, which is top to bottom. If I wanted to do a rebattement now, rebattement is just another word for rotation. If I want to do a rebattement to show the true shape of that surface, well, here's what I do. As I was kind of alluding to in the book, I just take my plane from here and swing it all down onto the ground. Okay? And you'll have done some of this for your question ones, for your true shapes before. So take your point and try not to do what I just did there. And the whole thing slips. Should take a bit more care with that. Take your point and swing it down onto the ground. And take your second point and swing it down onto the ground. Now, to do that in elevation, what does that look like in plan? Project it down in there first of all. Those 2 points project down. In plan, that swing, that rotation just looks like this. It looks like lines projected out, perpendicular to the horizontal trace. That's the HT and that's the VT. And I'll just explain that a little bit more now in a minute. But right there, it goes out perpendicular to the trace. And that gives me the true shape out here. So there is the true shape. And true shape simply meaning in various different views, this surface, the cut surface, well up here it just appears as an edge only, just as one single line. Down here in plan it appears as a rectangle, but a much smaller version because it was the correct depth, but that's the correct length and the true length of it. So in this view we have the correct depth and we have the correct length all in one. So that's a view that's called a true shape. And what we've simply done here is we have taken, if I just sketch this very quickly here, we have taken the plane that is truncating or is cutting the object, and we have rotated it down until it hits the ground. And in doing so, we've brought the shape with us, and we've found a true shape of the cut that was given. So if you give your best shot here as well as sketching this, the plane cuts it there, which gives me my true shape cut up here. So there's the truncated surface right there. The plane, we said it was 25 mil away or something here. It goes up in line with the surface. It cuts through the object like that. I have my vertical trace on the vertical plane. I have my horizontal, and this 1T will do on the horizontal plane. I hinged it here. Put on a couple of hinges there. And I cut down along the top part right there and took it away from that. I brought this with me. Bring my 4 points with me. And I'm doing my hinging. I catch it in and I swing it up. And this line stays exactly where it is. And when the object is swinging, as I'm looking down the plan, what does that look like? Well, as it swings, it just looks like that. It looks like it's coming straight across, which is what we did do here. It's coming straight across from where it was. And as it's swinging, what else? It's looking like you put your compass there and you swing down. And you swing down. And after all that thing, you get your true shape here. And that's what we have done now. We've done that in 2D. So I hope that kind of helps out and makes sense. But we put our compass here, where we're looking in along there at the elevation. And we can see the full plane as just one single edge. So we drop our compass here in the corner, where we can see the horizontal trace as one single point. And we drop the compass down, we swing it, and we drop it onto the ground. Those curves, as we look down and plan, they just look like, see the dashed lines I dropped in here? They look like these lines. So there's a truncated solid object, and a rotation or a rebatment is what we usually call it. And that's one combination of question. Now let's move on to something else. So we'll probably aim to get about 3 of them done during this lesson. And the next one I'm going to move on to is just on the next page, question 2, just up here at the top. We're going to do question 2 and 3 right now. And what we'll do as well this time is we're going to try and drop in an end elevation. So there's nothing different about this. We'll try and see if we can fit in everything. So the elevation, truncated, the plan. We put in an end elevation, and we're going to try and put in a true shape as well. Now I hope I've spaced in this page. I think I have. It's not a very big drawing. We'll see how I go. If I run out of space, I flick over the page and we'll go for it again. So we'll start off by drawing a 40mm side. 40mm side on this hexagon here, projecting up to elevation, which is 75mm tall. Now it's probably going to go over this projection here, but that's okay. Now I'm going to come in about 130. I'm hoping that that'll give me enough space to do what I need to do after. I'm going to start off here actually by drawing the plane. Now the plane is a 30-degree angle. I need 75 free space there for the elevation, so I'll actually start down there someplace. My XY line, and I have measured in 130, so I'm going to draw my plane from there. I hope that's enough space though. We'll see how it goes. There's the plane and plan, and this time around the plane is inclined at 30 degrees. Now if I come down 20 mil, from the XY line, and I come in 50 mil from the left. That gives me the starting corner of a 40 millimeter line. Now that defines the edge. Now, definitely when I run out of space here, I'm going to take this one off, drop on a new page. That's definitely too big. So, new page on, or flick it over if you're happy enough to. So, plenty of space this time. So I'll just pick a position here, anywhere at all, and I'll pick my 30-degree plane just there. And I was going down 20 and in 50 to start, and the edge of each edge or each side length is 40 millimeters from there, and that's going to be the side of a hexagon. So 60 degrees each way, and it's a regular hexagonal prism, so every side is going to be 40. And that's the plan fully drawn. The elevation projects just straight up from here. The total height before it got cut was 75 millimeters. I'll just project up one edge. I'll measure 75. Put the top on this guy here. Now that's before it got cut by the plane. And now I'll project up the remaining edges. Now what I'll do is I'll project them up. I'll go heavy as far as the plane, because that's all that remains after they get cut. I'll go light to mirror. The same here. Now these two line up, of course. We can't have hidden and solid, so we just prioritise solid. Same over here, those two lining up. Solid under. Just go light above, it's only construction up above it. And the last one is solid there. And there we go. So I'm going to just drop colour in there on the plane again. This time I'll just make it a blue plane. So there's the inclined plane that comes in across the object. I have my labels. There's my vertical VT and the HT. I'll number my edges this time as well, because we'll be doing a little bit more to this one. I'll just start here with number 1, which is the lowest edge that's cut. Number 2, 3, 4, 5 and 6. And I'd like to start off this time by just finding an end elevation over here. So what does this object look like when it's cut by the plane? It looks like the plan. As I said in the last, in the last question there, if any part of the prism remains the same shape, then the plan remains the same, because we can see all of the sides of the object in plan exactly as they are. Even if it gets cut at an angle, it doesn't really matter, as long as, well, the other little variation of that is if the plane was here and it went up through the top of the object, then you might have just a line to cut through, where you still have part of the top surface left, and then you're down with your slope. We'll come across that. Let's project off an end elevation and see what it looks like. So I'll just project over 5 and 6, 2, 3, and then 1 and 4 lining up. My XY line is probably a bit short. I project up 5, 6, 1, 4, and 2, 3. Now ignore the trace. That vertical trace now is not really part of what we're doing over here. That's only associated with the main elevation. And what do we have now? You'll have plenty of this done now from different drawings, and you'll be familiar with something like this from developments and so on. Point 1 is the edge, and edge 1 goes from the ground and gets cut right here. And that is in there, the center. That is number 1. As I look over at this side, 1 is the first one I see, so it has to be solid. It has to be a solid line over here. So there's number 1 done. Point 2 is on this line someplace, and the height is here. So there's 1 and there's 2, and I know I can join them. Now I usually wouldn't do this until after, but I'll just show it building up now. Point 3 is it's falling as I look over it in this direction. It's falling exactly in line with 2, and it's up here someplace. There. And then 2 joins up to 3. Point 4 is in the center line, and it's right here. Hopefully this is making sense now. Number it over here as you go if you like. Point 5 is on the right hand side, and it just lines up exactly with here. And while I'm here, I take this point through. I'm sure I need it. So point 5, and trace it both ways up. It's there. Point 6, the very last one, up on the same line. There. So that just shows an end elevation. Exactly what the object looks like when it gets cut in that end elevation right there. Next step, we're going to drop in a rebatment again and see what this looks like when we take the total length of the object, all the correct widths of the object, and map them down here together. I'll go a bit longer there with the XY line again. And I'll rotate or rebat everything. So starting off there with point number 1 up to what's next, 2 and 6. That's 3 and 5. And finally number 4. Bring them straight down. Finally, as before, straight across, perpendicular to the hinging line, or perpendicular to the trace. And what do I get? Well, as I said before, I get the correct widths anyway. And trace your points around. 1 goes around and comes out to here. 1, 2, 3, 4 is the widest one, which means 5 would be the next step in, and 6 is the final step in. And then join the dots in order again. So 2 to 3 and 5 to 6 are joining straight across there. And then 3, 4, 5, 6 and 1, 1 and 2. And we get our true shape. Again, hoping that makes sense there. So this time around, we've just projected off. We have found there's the plan view of the surface as just exactly as it appears in plan. That is the whole cut surface, but due to the way that we're looking straight down on top of it, it doesn't appear as a true size. Over here, we can also see the surface. And again, just because of the nature of how we're looking in at the object, we're just seeing it as much shorter than it is. We're looking straight across here at the elevation, so we're only seeing it from point 1 down below up to point 4 up above. We're only seeing it, for example, in this view, it only appears to be about 46 or 47 millimeters. But when I can take the correct true length and map that down onto the ground, I can see it's not 47, it's actually closer to about 93 or 94. Double the size. There's another truncated object, plan elevation and in view, and a rebatment and a true shape. One last drawing to do, and then we'll leave it at that for this lesson. Now this time we're going to just change up the plane. We're going to do this instead. So the two previous planes we were dealing with, we're just standing straight up here with a horizontal trace going up, and then we drop the inclination on the vertical side. This time we'll just change it up and go this way instead. We'll stand up our plane and we'll come out at an angle, so it'll be the vertical trace will actually be vertical, and then on the horizontal trace we'll cut out at an angle just like this. So that's all we're going to do right there. That's the plan. It's quite a big drawing this time actually, but we'll start off with a hexagon there, 38 millimeter side, right in the middle of the page, and we'll hopefully have space for everything I want to add onto this. So about another 10 minutes and we'll be finished this lesson. Now the plan is under the XY line is 125 millimeters. So I'm hoping, I think everything should fit here. Just pick a position there to start. The total width of a page is 420, so 210 is halfway. I'm just trying to keep this pretty close to halfway. And actually go a little bit to the right of that, because the plane, I don't want my hexagon here because the plane pushes past the hexagon. Or do I? No, I'll just go with it. So I'm going to set 38 millimeters up. If I want 38 off a center point, I'll go to 19 and then go from 0 to 38. Take that size on my compass, strike up. While I'm here now, I'll find the next point. It's always more efficient to use the compass once only if you can. Now we'll project down to plan, and they're saying leave a 20 millimeter space and then go 105. So I better just run that down as a construction first. Mark on my two measurements of 20, and then 105 will bring me up a total to 125. I can't heavy anything in because there's a lot of this going to be cut off again by the section plane. And what did they give? Well, what they gave on this plane was they gave it to the planes at a 60-degree angle, and it touches this point right here. So 60-degree inclination on the plane right there. So that is the plane we're dealing with this time. And we'll just go straight up here. Now, XY line, just take it all the way across the page. It's there, I have my elevation. The elevation stays complete because part of the prism still remains. Now, I'll explain that a little bit more in a sec. But what remains in plan? The prism only remains out as far as the point where it gets cut by the plane. So there. And there we go. So that's the part of the object that remains in plan. Should probably have you in that image as well, just on the plane there. And I'd like to go first of all and move on over here to the end elevation. Now before I do, all the way from this external point is cut right in along as far as this point, which is these two. That's all part of the cut surface. That's all cut there. So if I went shading, it's all cut, all cut, all cut. As far as where though? Where does it stop cutting the object? It stops cutting the object here. And from this point to this point remains the same as original. So I'm just looking and follow it up and down. It's there. Hope that makes sense now. That the object gets cut all the way from this external point right in along to here, and it's cut, which means if I was shading it in, I wanted to shade in the cut surface. That's as far as I could go. And the rest of it to the right, the little portion to the right hand side, remains untouched. It's not actually part of the cut. Let's go ahead and project an end elevation for a few minutes. And the end elevation, I'll start off, I'll forget about the cut for now. I'll just start off by projecting across the end elevation. I'll do all my projections. Sketch pencil, I'll do all my projections, then I'll actually go back and do my labelling after. So I'm going to start by calling that one point number 1, number 2, 3, 4, that's 5, and that's 6. 1 is going to be from here to here. So that's how much of it we're going to see in this new view. That would mean that I need to take the point where it's cut and project it. So in this new view, number 1 is the first thing I see as I look across. And it's just that little, whatever, call it 7 or 8 millimeter line. It's there. The whole back of the object is full. It remains a full, solid line. And edge 1 is from here to here. Next, up at the top, 2. It's going to go from the back of the object to the cut surface. So I'll take 2 across and up. Where is it? It's up at the top. So that's number 2 up above. And 1 joins up to 2, of course. There's number 2. 3 is much longer. Goes all the way out to the front actually. So 3 goes out to here. 3 is there when it gets cut. Right at the end of the cut, it's part of the front of the object, so 3 is here. 4 remains untouched, it's full, which is here. 5 is out in line with 3 at the front of the object, which is here. But this can be a little bit hard to understand or to comprehend it fully, but hopefully it will make sense now. 3, 4 and 5 did not get cut. Now, I know this, but I'm just following what it's telling me on the drawing. I'm basically following the points between the views. I've gone 1, 2, 3, 4, 5, 6 gets cut here, which I've already projected, which is on the ground. Number 6. And that is the cut surface. That's all I can see of the cut surface right there. Now that's getting a little bit closer, I suppose, to true shape because it's much, much bigger, but it is not a true shape yet. And to find it this time as a true shape, we're basically thinking, in a way, we're kind of thinking hinging the door, is what I'd be kind of saying here. And I just take something like these, the colour pencils, drop them in. Well, that's what we're able to see. And we're going to catch it now around this back edge here, and we're going to hinge it out until it reaches the plane and we'll see what it looks like in the elevation. So bear with me on this one. We'll be all finished now in a minute. So it's just the points on the red plane from that point right there. I'll tell you more about that point in a sec. I'll take point 1 around onto the XY. I'll take point 2 and 6 onto the XY. And what else have I? 3 and 5. Now this time 4 does not feature. Why? Because it's not on the cut surface. Okay. What I did have here is that is the vertical trace and that is the horizontal trace. As I look down on top of the line, I'm getting a point view of the vertical trace, and I'm also getting an edge view of the flat plane right there. That's just a little extra there. I have point 2 and 6 here at this point. 2 and 6 are right there. 1 is right here, and then that one there is 3 and 5. So I've rotated them around, and I'm going to just project them across from the elevation. So 1 comes across, 2 and 3 come across, 5 and 6 come across, and as I said, 4 doesn't get cut. What do we have? 3 is all the way around here. 5 is all the way around as well. Let's change over to my colour for labelling. 3 is there, 5 is there, 2, 1 is this near one here, and 6 is down here. And you join the dots. I think some people are probably, if you're gone this far, excuse me, if you're gone this far and you're doing this drawing with me, you're probably saying, hang on a minute, are they not the same thing? We'll just check in a second. What I'm going to say is no, they're not, because I leave space for my label here. This one here is our true shape. And a true shape should be the largest possible view of a surface, and all them other views as it appears there in the elevation and as it appears over here, they're not showing us any they're not showing as a true view. Let's check it. The distance from one out to the end in this one here is about 96, and in this one here it is 111. So this one is much bigger. It's taking the true lengths and the true heights and bringing them together. This one here only has true heights from the elevation, but it has projected lengths. It doesn't have this length from the plan. It only has this length, which is 95 instead of 110. And there's my rebatment shown again. So there's 3 nice little examples, and I hope you've enjoyed doing them. 3 good introductory examples into geometric solids, getting cut by planes, doing rebatments and true shapes. And it's a huge topic at Leave Insert now, like this is, and it feeds into so many little extra topics at Leave Insert. So, as I said, hope you've enjoyed the lesson. Thanks for tuning in, folks.